One.
Okay, this is our stealth fighter, and yeah, we'll present it.
Alright, so here's some background knowledge. It's the first aircraft to give off a low observable stealth technology. State-of-the-art technology improves navigation and attacks. It can carry a lot of weapons. It's the first F-117 was delivered in 1982. The last delivery was in the summer of 1990, and the first flight was in 1981. Virtually indestructible, and the materials, they absorb the radar, so it can't really detect it.
Alright, so why stealth? It's built so it can't be seen on radars, like it said, so it can't be detected. It can send and receive messages and images with ease. Mission planning technology reduces confusion. Operates with laser gyroscoping and GPS receivers for precise angles. Angles of the service bounce off the radar beam, which is why there's no 90-degree angles on the plane. There's other ways that it absorbs the radar's signal that it puts out. And the reason it absorbs it is because it's a wide and flat structure. And the engine exhaust is thrown off course by these two things.
Alright, so to find the dimensions, well, we Googled it. And then we had to, I had to convert everything into inches, because I just found that easier to work with our model to scale it down. So basically we took the feet and multiplied it by 2, because you all know that 12 inches are in 1 foot. And then you just add the inches, so you would take, for instance, 65 times 12 plus 11 would get your inches. And then just do the same with all of the height, wingspan, weight, not really, but yeah.
Okay, so we chose a scale of 1 to 72. So for every inch, it equals 72 feet in real life. So basically, it's pretty easy to scale things down. Once we converted everything into inches, we just divided that measurement by 72. So yeah, we did that for all the length, height, and wingspan, because that's what we were given. We didn't have any of the other things yet.
So to find the general shape of it, since the pictures don't do it justice too well, we cut the plane into 2 halves, going vertically up and down through the plane to make a right triangle, which is triangle with a right angle. And then we use the Pythagorean theorem, which is a squared plus b squared equals c squared, which basically means we knew that 2 of the 3 sides can be used to find the 3rd side. So we now have a right triangle. It was possible to use this math function. After plugging in the side measures, we knew which were the length and width of the plane. We got a quite large number that was then unsquared, because it's a squared plus b squared equals c squared. And the final product was the length of the hypotenuse or the largest side,
So it was this side here.
which is the wing side. And that is the longest, which came out to be 11.56 inches.
This is our diagram we used to make all that stuff.
Technically we use 2. There's another one like that.
So it's just one of them of the 2. So.
This is what we use to find the general shape, and then that one's what we use to find all the angles.
Alright, so getting a little more complicated here. After finding the general shape of the plane, which is a triangle, we found that the triangles on the bottom, just the tails. So cutting the triangles down the center to make a right triangle. After finding the sides, we use the Pythagorean theorem to find the hypotenuse. These triangles' measurements will be used to accurately recreate the plane in scale model.
Alright, so we scaled down our triangles measurements. So the outer ridge measurement was 45.63. That would be, what measurement would that be in?
No, that's inches. And
That'd
then this is just after we divided it by 72.
Yeah, basically.
Alright, so since we need to find the wing dimensions of the outer part of the plane, which is right there, we use proportions to find it, and it looks like that. Just, we have it all over our paper in crazy numbers.
Okay, so the thing that's special about it is it has all these crazy panels that bounce off the radar signals, so obviously we needed to find those. So we used proportions to find this, and so down here is an explanation of what a proportion is. So basically, we know the length in real life, and then we measured it on the paper. So you set the length in real life, or the measurement on the paper over the length in real life, and then set that equal to what you measure on the paper over X because you're trying to find what it is in real life. And then after that, I mean, it can be anything, but basically we used the length of it, which we knew was 791 inches, I believe, and then over what we measured on the diagram, which
Which
I
was
don't,
6 7/8.
yeah, we put those 6 7/8 over 791 equal to what we measured, just any of these over X, cross multiply, divide, get a number, scale it down by dividing by 72. So then after we found this, well, okay, you can't really see it anymore because it's covered in panels, but we found this shape here. We went off of that and found all of the angles and things that went on that. That just gave us a base to start with. And then we used a protractor because all the angles, if you're making a similar model, the angles stay the same even in real life.
So as we built the plane, we continued to use proportions, so now the plane looks like this.
Alright, so we made it, the plane, the base out of clay first, and it was easy to cut and mold. But then the glue gun was just like, I'm not gonna stick to this clay, so then we switched to cardboard, and then it was a lot easier to make it that way. And there's our works cited.
Do you guys have any questions for them? Okay, so you said you did we can't see something in the middle. What do you mean we can't see something because of the panels?
Oh, okay, there's like the general shape, you know, there's like it goes like this.
Kind of like a side
Yeah.
view.
Okay.
We just cut a straight panel out of that so that we could build things off of that.
Oh,
That's all that.
so there's a kind of a skeleton inside.
Yeah, like
Okay,
a spine.
very good. Awesome.
Do you want this still?